Hey, it's me and Sadie again. As you know, solutions are made up of two things, a solute and a solvent. Now, in today's lab, we'll be exploring the properties of both using a potato.
And suddenly I'm hungry for French fries.
How can you be thinking about food when we've got so much exciting science to do?
Fine. In this first part of the experiment, we'll be investigating osmosis by placing potato pieces into three different solutions. One that is hypotonic in regard to potatoes, a second one that is hypertonic, and a third that is isotonic.
We get to use the potato borer. Now be careful because this bad boy can bore a hole right through your hand. Make sure you hold the potato on the table like this and push the borer in like this.
Now, if the potato piece gets stuck inside the cylinder, just use a glass stirring rod to push it through, like that. Make sure that you label all your weighing belts so that you do not get everything mixed up. And also, when you're recording your masses, make sure you measure up to 3 decimal places.
After you've recorded all these measurements, you'll want to place each of the potatoes into their respective solutions. Now, they'll need to stay in these solutions for 45 minutes. So go ahead and continue on with the rest of your lab while you're waiting for these 45 minutes to be up.
After the 45 minutes has expired, you'll remove the potato pieces and remeasure their textures, lengths, and masses. By comparing the potato pieces before and after the 45 minutes, you can make conclusions about whether the water flowed into or out of the potato pieces.
And remember that water always flows to the higher solute concentration. So the potato that gained the most mass gained the most water. And if your potato lost mass, it lost water.
Once you're done, you can throw away the potato pieces and dispose of the solutions that are in the beaker into the sink.
In the next part of the lab, we'll be using nickel sulfate to create different complex ions.
When salts containing transition metals dissolve into water, they make cations that form covalent bonds with molecules like water and ions like chloride. These then result in complex ions.
Today we'll be using a volumetric flask. Now, volumetric flasks are very expensive because they're calibrated to accurately measure up to 2 decimal places. Now, in today's lab, we'll make a lot of different complex ions with the nickel 2 ion. And what's cool about each of these different ions is that each one creates a different unique color solution.
This one is pretty great. You'll know that you've made a new complex ion when you observe a color change of some sort. Like this one. Katie will add ammonium to our nickel sulfate solution. Then you'll notice a color change.
That's pretty cool. Now, making complex ions isn't that complex after all.
I see what you did there. Very funny.
Anyway, once you've recorded all your data, be sure to properly dispose of your nickel 2 sulfate solution, and then clean out your volumetric flask thoroughly before you put it back on the cart.
And now I can go get French fries.
But hey, make sure you wash your hands because we dealt with a lot of harsh chemicals today. Have fun in lab today.